Students, in this video we will discuss single line diagram of components and its so what are components we are using to design like single line or design power supply single line diagram. So that components we are going to discuss now because it is needed. So if you are using any symbols or any electrical appliances or electrical components or power system components, we should know the working, or we should know why we are using that particular power system components, right? Let's see one by one. Power transformer which is used to transfer the power from one place to another place or one circuit to another circuit without changing its frequency. Where exactly we are using this type of transformers? In the generating side, transmission side and distribution side, everywhere we are using transformer. Step up purpose, step down purpose, constant voltage purpose, everywhere this type of transformers we are using. So in this power system particular power single line diagram, we are using this transformer in the auxiliary power supply side, input side, output side, and in between from incoming to outgoing also we are using power transformer. And next is there is a current transformer. What is the use of current transformer? Current transformer is used to measure high current CT in the transmission lines, because normal voltmeter ammeter we cannot use, right? In the transmission line or in the transmission transmitting the power from generating station to substations. So there we are using CT. CT is for to measure high current. And next we are having a PT, potential transformer. Potential transformer is used to measure high voltage. We cannot use voltmeters, normal voltmeters for measuring the high voltages. So this transformer we are having PT we are having for measuring the high voltages around 11 kilovolts. Like secondary voltage 110 volts. So 11 kilovolts also we can measure. And current transformer range around 100 1 amps CT. Okay. So 100 amps input side, 1 amps output side. Okay. What is the use of circuit breaker then? Circuit breaker which is used to break the circuit when abnormal condition occurs, fault occurs, short circuit occurs. So that's why we are having a circuit breakers, right? Next we are having a isolators. Isolators is for isolating the particular area. Best example I can say, unequal to our college, in between, if you want to repair, if you want to do something, or if you want to switch off power supply, there we can use isolators for maintenance purpose, for repairing purpose, for manual also you can shut down as your wish. I mean the BESCOM people wish, right? That's why we are having a isolators. Okay. And see, just you read the topic. What is the isolator? Isolating switches. And lightning arrestor. What is the use of lightning arrestor? Again I am telling you, lightning arrestor is for arresting the lightning appears when the rainy seasons and all. If suppose if you are not using lightning arresters, if your luck is not good, so the whole building will damage. I think you might have seen in the newspaper also. There is a farmer. He got lightning in the rainy season. So he farmer deaths. That whole tree becomes like dividing. Whole buildings becomes like damaging. That could be avoiding by using lightning arrestor. See, lightning arrestor is like a one like a cone, like a structure pole. That pole which avoids lightnings when lightning appears. Either the lightning will escape or it directly goes to the earth. I mean, whatever the leakage, it directly goes to the earth. That is lightning arrestor. It should be used in the power system components. And also I can give another example like lightning arresters. In the anecal circle there is a lamps are there, right? Like street lamps. In the top we are having a in the circle street lights. You can check there. There is a one cone like poles. Rod like structure they kept, because to avoid, if suppose lightning appears, it should not affect to that lamps and all. If you are not using that lightning arresters, sometimes the whole system will damage, whole that lamp systems and all are damaged. Otherwise, it will get melt also if suppose you are not using. So that purpose we are having a lightning arrestor in the power system components. Even though you can check all the towers in the transmission lines, it's like a cone-like structure. They used to keep on one rod because for safety. And earth switches normally kept open, connected between the earth and a conductor. If the switch is closed, discharge electrical charge to the ground and available to uncharged lines. Okay, that purpose are things which we are using. So whatever the discharge, I mean like leakage current directly goes to the earth. And wave trap. See, wave trap is very important. This equipment is installed substation, trapping the high frequency communication signals. I told you right, Airtel, Jio signals and all. So to avoid a disturbance, we are having a wave trap. So for the remote substation, the delivering them the telecom panel, substation controls room. See, this wave trap is for if suppose substation to substations there is a controlling. I mean like a signal controlling or communication lines will be there, or communication must be done. So that communication should be proper. It should not be distracted with the other communication lines. That could be avoided by using wave trap. At present we are having mobile, right? No need of this wave trap, because if I call somebody like particular in charge in the other substations, no use and all this wave trap and at present. But previously it is needed, right? That is wave trap. And coupling capacitor is for couple adding purpose. And bus bar, so it carries the power supply, input or output. It's like a majestic buses will be there, input and output, everything will be there. Okay, when it carries power supply, it's like a carries the passenger, right? BMTC bus and all. So likewise carries the power, voltage, current, everything. We are having a bus bars. And single bus bar arrangement, double bus bar arrangement. Single bus bar, only one bus. I mean like joint bus will not be there. And also like top also they used to keep, right, buses. And here single bus bar. It consists of a single bus bar. Both incoming and outgoing lines are connected to the single bus bar. Incoming and outgoing lines are connected to single bus bar. Okay. And this is on diagram for your understanding purpose. See, 3 incoming lines and 3 outgoing lines. And bus bar is present, right? So this is lightning arrestor. This is circuit breaker, and this is CT, and this is isolator switch, and this one is PT, normal transformer. These are the outgoing, these are the incoming lines. Okay. Next, single bus bar with a sectionalization. So like this, single bus bar with section. Okay. So 4 incoming lines, 4 outgoing lines. Right. This is one diagram for incoming and outgoing. And double bus bar arrangement. 2 buses will be there. 2 bus bars will be there, and double bus bars will be there, and incoming and outgoing lines will be there, and all the electrical power system components are there, right? That is a double bus bar arrangement, right? So again I'm telling you, this is the best example for a single diagram. See, incoming lines from power stations and outgoing lines from the power stations are this one, right? So this is incoming and this is the outgoing lines. So we kept so many electrical power system components in this particular single line diagram, right? So likewise we will solve some problems. I'll be giving input and output, how many incoming lines, how many outgoing lines, and what are the power system components we need to keep, and everything we will discuss. Okay, we'll solve these problems in AutoCAD 2017 or 2014 2015. Please download AutoCAD 2017 or 2015 2017 in your laptop. If you are not having laptop, we'll practice in our college laboratory. So definitely, so thank you so much. Please go through the previous videos for better understanding. Thank you.